Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. In this video, we will look at some exam questions on the topic called waves. On this topic, there are two equations that you will have to use. The first equation is speed equals distance divided by time. Second equation is speed equals frequency times wavelength. Now we can write these equations in the form of symbols as well. That it will become V equals F times lambda, where this is the symbol for the wavelength. The first one can be written as V equals D divided by T. Now the type of question that you can expect on this topic are: number one, calculate. So if there's a question on calculate, then you'll have to use one of these two equations. Number two, there could be about explaining situation. So they may ask you about explain, and the third one will be about investigate. Now when it comes to investigate, they may ask you to, a student is trying to investigate the speed of sound. In that case, you will use this equation, or you may have to measure frequency or wavelength of a wave. So you will need to know both of these. What is frequency and what is wavelength? If you recall, frequency is the amount of waves which are produced in 1 second, or I can say it's the amount of waves which are passing a point in 1 second, whereas wavelength is the length of one wave. Let's have a look at the first question. The first question says there's a sound wave and it travels at a velocity of 1530 meters per second. So this is the value of V given to me. Remember, annotation is very important because it will guide you and it will let you pick up the right equation that you will need in order to solve calculate questions or even for investigate questions. The frequency of the wave is 1.2 kilohertz. Now I see here it is kilohertz. I can't use frequency as kilohertz because my unit of frequency is hertz, so it will require unit conversion. So I can say this is my frequency. It will have a value of 1.20 times by 1000, and this is now in hertz. It will carry 1 mark out of 3. Last part says calculate the wavelength. I don't know the value of wavelength. I'll simply put a question mark for it. All I have to do is pick up equation that contains these 3 letters, which is V equals F times lambda. V equals F times lambda. Substitute the values, you'll end up with 1530 equals 1.20 times by 1000 times by lambda. If you solve this equation, it will give you the value of lambda. Next question talks about sound travels slower in air than does in water. Now this is very important information for us, because I can use this information and work out what will be the speed of sound in these two different materials. So it says slower in air than it does in water. So I can say here sound will be fast. Here I can say sound will be fast. Here sound will be slow. It says figure 9 shows the direction of travel of a sound wave approaching a boundary. So we know every time sound approaches a boundary, what will happen? It can enter into new material. It can also reflect, and it can also get absorbed. Okay, so 3 things can happen. It says sound wave refracts at the boundary between air and water. This means it will enter into new material. Complete the diagram in figure 9 to show the direction the sound wave travels in the air. So you have to recall, when you go from fast to slow, it always bends towards normal. So I can say in this case, this is the normal line. If you recall, normal line is always at 90 degrees to the surface between two materials. Here it says bends towards, so this means if it was to carry on moving straight, then it will take this path, but it has to bend towards normal, so I'll have to draw a line towards the normal. Okay, and that is my answer. If it was light, then the opposite will happen. So make sure you read question very carefully. Next question says dolphins emit sound at many different frequencies. Complete the sentence by putting a cross in the box next to your answer. A dolphin can produce sounds with a frequency of more than 20 kilohertz. Now if you remember, there is human frequency hearing range, which is 20 hertz to 20,000 hertz. In other words, this is same as 20 kilohertz. If the sound is below this, then it is classed as infra. If the sound is above this frequency, then it is classed as ultrasound. So in this case, it says these sounds are called ultrasound. Why? Because they have a frequency greater than 20 kilohertz. It says a dolphin is near to a group of fish. Describe how a dolphin uses high frequency sounds to locate the position of the fish. You may add to the diagram to help your answer. So you need to remember, to locate the fish, what it does is, number one, the dolphin will produce high frequency sound. It will emit high frequency sound. What will this sound do? It will travel towards the fish. Now when it will reach the fish, there will be change in material, because it will be water and fish. They are both of different material. What do fish do? It will reflect the high frequency sound wave. Then what would happen? The wave will travel back to dolphin. So I can say wave is detected by the dolphin, and then the dolphin will be able to calculate how far the fish is. Okay, so if you write down 3 bits, you will get marks on this, right? So the dolphin will emit high frequency sound, it will travel towards the fish will reflect this sound back, and the dolphin will receive this sound. Let's move on to the next question. This question is about investigation, but majority of the work has already been done in this question. So what are they doing here? We've got 2 students, P and Q. What are they trying to do? They are trying to measure the speed of sound, right? In this case, this is the value of t. So I need a value of t. So the equation that applies to this situation is V equals d divided by t. It says P claps his hands together. When Q sees P clapping his hand, she will start a timer. So Q has the timer. When Q hears the clap, she'll stop the timer. Now this could be, let's say, 3 marker in your exam. How will you measure speed of sound? So you have to remember this arrangement. You can have 2 people like that. One person will be responsible for clapping. The other person will be responsible for recording the time. But you'll have to mention when will they start and stop the stop clock. So that will carry marks, right? So make sure you know this situation. It says explain one way the student could improve their method. Now to improve their method means they want better results. To get better results, what they need to do is, we can say, because they've got the timer and there is always error in time, so we need to reduce that error. So we can say, number 1, distance should be increased. Now because it's explained, you have to tell what will happen as a result of this. So if your distance is increased, that means there will be smaller amount of error in time measurement. So we can say lower error in time measurement, and this will improve the method of investigating speed of the sound. Next question. Many earthquakes and volcanoes are linked to the production of infrasound waves. So what are infrasound waves? If you recall, these are the waves which have frequency is less than 20 hertz. For them, the frequency is less than 20 hertz. It says describe what is meant by the infrasound waves. It says describe what is meant by infrasound waves. So you need to recall, these are sound waves with frequency less than 20 hertz. Okay, so you have to remember sound waves with frequency less than 20 hertz. Let's have a look at the next question. Here it says figure 2 is a diagram of water wave. So the moment I see water wave, I can recall these are transverse. These are transverse waves. It says the cork is floating on the water. Now I do want you to remind, I want to remind you here that what do waves do? Waves, they transfer energy, number one, and sometimes information. You have to remember, they will never transfer material. Cork is floating on the water. Use the scale on the diagram to measure the wavelength of wave. What is wavelength? It is length of one wave. How many waves do I have in total here? If I look at this diagram carefully, you will notice there are 2.5 waves given to us, and the total distance is 30. So I can do 30 divided by 2.5, and that gives me 12 cm. Therefore, the wavelength is 12 centimeter. Next question says describe the motion of the cork. I know it's a transverse wave and it is going from left to right. So the cork can't move left to right. It will move at 90 degrees to the direction of travel. So I can say it will move up and down. And if you write down oscillate 90 degrees to the direction of energy transfer. So you get 1 mark for this and 1 mark for mentioning that it is 90 degrees to the direction of energy transfer. Let's have a look at the last question here. It says figure 7 shows a tuning fork. When the prongs of the tuning fork are stuck, the prongs vibrate in the direction shown by the arrow on figure 7. So this prong will move left, right, left, right, left, right. Describe how the vibrating tuning fork causes a sound wave to travel through the air. Remember, what is sound wave? It is longitudinal. Travel through the air. You may add to the diagram if it helps you. So what's going to happen is there will be air particles next to the prong here. So when this vibrates, it will make those air particles vibrate as well. So we can say prong will make air particles vibrate. Now when they vibrate, in what way will they vibrate? So you have to remember the energy is traveling from left to right. So you have to say in the direction of energy transfer. So the energy will get transferred from the left side towards the right. So the air particles will vibrate horizontally, okay, and that will get you 2 marks. I've done a couple of questions for you here, but there is more than this that you need to know, but this is absolute minimum. I hope you'll find this video useful. I wish you all very good luck with your exam preparation. Thank you.